So let's just assume we have a list of 5, 8, 3, 2, 1, 15, and this would be a random list. So here we have to search for an element. So as in the last question we have shown, we can use linear search or the binary search, or there are more modified versions such as sentinel or ternary search, but for now let's just assume binary is the best solution we know. But whenever we try to apply a binary search, basic condition is that the list should be sorted. Means each of the elements should be arranged in such a way that it is either increasing or decreasing. So kind of here 5 is less than 8, 8 is greater than 3. So here we are getting a mismatch. Either it has to be decreasing or increasing order. So if we try and find out the sorted list of this, then we get 1, 2, 3, 5, 8 and 15. So this is the sorted list on which we can then simply perform the binary search, and we can easily find out the element in n log n time. So basically the process of conversion of random elements, randomly ordered elements, into either decreasing or increasing order, are also called as sorted order, is called this function, this process is called as sorting. So basically we have to sort this thing. So here let's just take the same example and try to sort this thing. So for sorting, what I can do is I can search for the minimum element in this list and put it at the first position, because we have to start from low to high. We are doing this in increasing order. So then I have to find the second minimum element, which is 2. Similarly, we have to find the next minimum, next minimum, next minimum, and the next minimum. So slowly we get the whole array as a sorted thing. But how can we find the next minimum? First minimum is an easy process that we can use a for loop. But then how we can find? So what I can do is I can remove this one from this list and then check for the remaining list. So like this I will find the next minimum element. So I can then remove 2 and then check for the same element, check for the minimum element in the remaining list. So here what I am doing, I am taking the minimum element and storing it somewhere, because I have to create this as a sorted list. So I have to store this somewhere. So what I can do is, whenever I get the first minimum, I can put it in the first position. Then for the second minimum, I can put that in the second position. And similarly, each position will be changed and our list will get sorted. For example, if we again try how we can do this. So let's take the same example and try to think how we can work on that using the previous approach. So here I can find the first minimum element, which is 1, and then I can shift that to the first position. So now the list will become 1 and the remaining all elements. So now I can assume that this part of this list is in sorted order and the other part is in unsorted order. So I can again implement the same thing of finding the minimum in this part of list and again putting it to the first index. Again the list will be decreased, and again finding a minimum element and then adding it to the next position. So like this we can do. So let's just try to do this on a new list. So as we saw, we first find the minimum element and then we shift this to some appropriate place and then say that part of the list is sorted. So here we can keep a pointer which would point the part, or which would separate two parts. So the left part of this pointer would be sorted list and the right part would be unsorted list. So whenever one will be added here at the 0th position, so I can say pointer is here, this all right part is unsorted and the left part is sorted. Similarly, next element 2 will come to this position and now the list will become sorted, list would become 1 and 2. This is sorted, the pointer would go to the next element and this whole part is unsorted again. So similarly we can do this thing, and at last we would get a whole list which would be sorted. So here we are going to the 0th index and pointing it and saying the left part is sorted and right part is not sorted. Then finding the minimum element, which in this case is 1, and then we are swapping it with that position. So why are we swapping? If we try to shift the element, then we know each element has to either shift it to left or right. So if we consider the worst case time complexity, then for shifting each of the element one place right, it would take order of n time. So instead of shifting, what we can do is we can swap that element, because it won't affect the list. Why? Because we know the minimum element would come at the first position and other element will automatically get arranged as we are going further. So going to the first 0th index, we swap, then we increment the pointer, we go to next index, then again check for minimum element, then again we swap, again go for next element, swap, swap and swap. So we stop here at the n-1th position. Why? Because let's just assume this whole part is sorted. So 1, 2, 3, 5, 8. So this part is sorted and last element remaining is 15. So as we know, these n-1 elements are sorted somehow. So this whole part is sorted. Then there is no need for sorting this last element. As we can say, n-1 elements are sorted, then no need for sorting the last element because it will be automatically sorted. Why? Because if, let's just take example of 5 students of increasing height. If the heighted member goes to the last and short members comes to the first and goes on in the increasing order, then the last member which is left, he don't have to change his place. Why? Because he is tallest and he is standing at the right position. Why? Because in front of him, whichever children were there, they are in the correct position. So there is no need of changing of the last heighted member's position. So similarly, in the last case also, we don't have to check for the n. Why? Because we can say if n-1 elements are sorted, then automatically the last element is also sorted. So let's just try to implement this thing in our code. So let's just go to the text editor again. So let's just create a function called as selection sort. So the thing we just saw, in which we select the minimum element from the list or from the part of unsorted array, we select the minimum element and shift its position. So this thing is called as a selection sort algorithm. So let's just take some parameters. First of all, the array or the list, let's just take A. Then we won't require anything, so we would only require the array. So what we have to do, we have to go for each index up to n-1. Why? We consider that index as a pointer and the left part of that pointer would be sorted and right part will be unsorted array. So let's just take a for loop. So for I in range, so we will go up to length of A minus 1. Why? We just discussed. So last element will be automatically sorted. So for I in range, length of A, length of array minus 1. So what we will do here is we will consider the min index. For start would be I. Let's just consider the first element is the minimum element for now. Then what we have to do, we have to check for each of the element in the unsorted array. So for j in range, so the range would start. So let's just move on to this thing again. So here currently we are at the 0th index, so we'll start from 0, but after 0, if pointer moves 1 point ahead, then we have to start from that index because left part is sorted. So at whichever I position we are, we have to start from that up to end. So from ith position up to n. So we have to start from I. So here, therefore, we will start from I up to the length of the array. So we will start from I, which is the pointer with separate sorted and unsorted part up to the last element, because that all part is the unsorted array. From that, we'll find a minimum index, a index which represent the minimum value in the unsorted path, so that we can swap them. So if array of minimum index means the index which we have assumed has the value greater than a of j, means any value in the unsorted path. So what we can do is we can modify the minimum index to j. So at the end of this for loop for j in range I to length, so for this loop we would get an index such that it is the minimum in the unsorted path. So whenever we get this minimum, we can then directly swap this with the ith element. Why? Because I is the pointer. So we have considered I as a pointer, so we can directly swap. So instead of using the swap function, I will use the tuple unboxing. So it is kind of a way with which we can swap the elements. So let's just do this, and let's just try with an example. So a equal to, let's just take list some random elements. So let's just take these elements and implement selection sort. So selection underscore sort and then a. So let's just print a before and afterwards. So print unsorted array and then the a. Similarly, after selection sort, we'll print this sorted array. So let's just execute this and see. So at first the same a is printed, which was randomly ordered, but after performing selection sort, we can see the whole list is sorted in ascending order. Similarly, let's just print each step so that we get an idea how is it working. Print a. So here we can see at first for the first position, what we did, we swapped the 7 and 2. So 2 was the minimum element, so it came at the first. Similarly, for the second loop, 3 was brought from the last index to the first index. Similarly, then 4, 9, 7, 10 and 5. So for each of the elements, we swapped and created a list. So we are basically printing each of the step. So this is the basic working of selection sort. So why is this called selection? Because we select a minimum element and then arrange its position, and then we can separate out which part is sorted and which part is not sorted. Therefore it is called as an selection sort algorithm. So this was all for this lecture. Let's just meet in our next lecture.